All right. Good evening, good morning, good afternoon, whatever it may be for you right now. But talking about trigonometric ratios, trig ratios should have been presented to you possibly at the end of your algebra courses. But what we're talking about here is we're talking about ratios of sides based on the angle. So we want to, and we'll go into some examples, but given an acute angle of a right triangle, label the hypotenuse, the opposite, and adjacent sides. So we want to be able to, make sure that we can label our triangles properly to where we know how to use our trigonometric ratios. And then, given given the given an acute angle of a right triangle, we want to write the ratios for sine, cosine, and tangent. And then relate those trigonometric ratios to similar triangles and the acute angles of a right triangle. So let's see. I will just say that you're going to hear the term or the phrase or the mnemonic SOHCAHTOA, and that is SOHCAHTOA, and that is talking about sine, cosine, and tangent. Here is my sine, my cosine, and tangent, and we will use those interchangeably, or not interchangeably, but and just knowing our ratios and being able to label things, because here where we're talking about sine is the opposite and the hypotenuse. These are some words that we're going to have to learn to be able to recognize in our triangles. So we'll start by talking about special right triangles. Now, special right triangles are things that, again, you should have been familiar with up and before this point, and they are, in this case, this first example right here, we have the 45, 45, 90. So this is going to be 45 degrees, 45 degrees, and then 90 degrees. And if you use your Pythagorean theorem, we would have a squared plus b squared equals c squared. Well, if this is a, this is b, that would be 1 squared plus 1 squared equals c squared. And in this case, we have 1 plus 1, or 2, equals c squared. And then if we find the square root of both sides, c is going to equal the square root of 2. So that is just proof right there that when I have equal sides, then it's going to be the square root. So 1 squared plus 1 squared is going to equal the square root of 2. Or should I say the side length of 1? The side length of 1 is going to equal a hypotenuse of the square root of 2. And then and this is just a ratio. And the same thing goes here for the 30, 60, 90. All right, so when I look at the 30, 60, 90, this is going to be 30, 60, 90. My ratios are going to be, corrected here. Dude, made a little mistake. My ratios are going to be 1 square root of 3, and then 2 would be my hypotenuse. And again, if I think of this as A, this is B, and this is C, that would be 1 squared plus the square root of 3 squared equals 2 squared. So I'm going to have 1 plus 3 equals 2 squared, which is 4 equals 4. So it's just the ratios involved with those side lengths. And they can expand out as long as the ratio remains equivalent for all sides. So just looking at those special right triangles as we go. Now, labeling my sides. All right, so here's where we need to make sure that we are able to label these sides properly. So when I look here at angle B, let's go with angle B. Angle B, I need to say that the opposite of angle B is going to be that side over here. Little b is going to be the opposite of angle B. Now, adjacent to it would be the leg that is next to angle B, and so this would be the adjacent. So when I have angle B, the adjacent is going to be, adjacent will be BC. The opposite will be not AB, but AC. And then the hypotenuse is going to be that longest side right here, and that is going to be side length AB. So being able to look at those and see what the corresponding side or length will be. So when I look at angle A, of course my hypotenuse is going to remain the same, right? My hypotenuse is going to be still AB, right? Here's my hypotenuse. My opposite is going to be right across from here. So my opposite is going to be segment CB. And then my adjacent right here, this would be my adjacent. So my adjacent is going to be AC. Okay, just your opposite or your hypotenuse your hypotenuse will remain the same, but your opposite or adjacent will depend on which angle you're working with. And so again, being able to label it and knowing that, well, across from my right angle, of course, will be my hypotenuse. So just being able to label your sides. Tangent. Okay, let's go back here for a second. When I talk about angle B, the sine of angle B is going to be the opposite over the hypotenuse. And that means that the sine of B is going to be, let's see, let me go ahead and get some standard stuff in here, right? So my side lengths are going to be AC. So the opposite is going to be, the opposite of angle B is going to be little b. And that is going to be over the hypotenuse, which is C. So there you go. The sine of angle B is going to be B over C. The cosine of B is going to be the adjacent over the hypotenuse. So cosine of B is going to be, the adjacent of B is going to be little a, right here, A over the hypotenuse, which we said was C. And then the tangent of B is going to be the opposite over the adjacent. Okay, so again, for angle B, the opposite would be little b. Little b over the adjacent, which was little a. Now these are just ratios, you know, the tangent, the sine, the cosine are ratios of sides of a triangle. And that's where earlier when I spoke about SOHCAHTOA. SOHCAHTOA. And that means the sine is equal to the opposite over the hypotenuse. The cosine is equal to the adjacent over the hypotenuse. And then tangent is equal to the opposite over the adjacent. So that's where the SOHCAHTOA comes into play. So again, let's see here. Let's clean up this next image. And I'm going to go ahead and do some relabeling here, just to make it a little bit more conducive. Get rid of this junk. Not conducive, but yeah, a little bit more educational value here. So if I go with M, N, and O, that makes my side links are going to be the little ones. So I got little O, I got little N, I got little M. Those are going to be my side links. So remember, SOHCAHTOA. And we just go ahead and cut that out and bring it down there so we can look at it. SOHCAHTOA. There you go. May have missed a couple of things in my cut, but that will be over the opposite, and that's sine. Okay? So looking at that, I want to know what is the sine of angle N. Well, the opposite of N is going to be little n over here, and then the opposite, or the hypotenuse, is going to be O, right? That's my hypotenuse here. I'm just going to go ahead and label that one so we know. And then the cosine of angle N is going to be, well, cosine is going to be the adjacent over the hypotenuse. So the adjacent to angle N is going to be M over the hypotenuse, which we said was O. And then my tangent of N is going to be the opposite, right? The opposite, which we said was M, over the adjacent, which we said was N. So there you go. I'm able to calculate that information just by its orientation. And if we do the same thing for angle M, so my sine of M, my cosine of M, and then my tangent of M. Well, the side ratios for sine is going to be the opposite over the adjacent. So the opposite is M, not adjacent, hypotenuse. Opposite over the hypotenuse, so that is going to be M over O. Cosine is going to be the adjacent over the hypotenuse, which is going to be N over O. And then the cosine, or tangent, is going to be the opposite over the adjacent, so that would be M over N. Just being able to recognize the sides according to whatever angle we're working with. Now, when we talk about sine, cosine, and now, what is the length of MN right here? Well, if I look at that, and I'm going to have to make some assumption here that that's 90 degrees because we're working with sine, cosine, tangent. And so, what is segment MN? This segment is dealing with this angle possibly. So we're going to use sine of L to go ahead and cosine of L and tangent of L to figure that one out. And it looks like as I'm looking at angle L, I can see that I have a hypotenuse. And then 15, that would be my adjacent side. And then this one over here is going to be the opposite. Well, I know that cosine is going to be the adjacent over the hypotenuse, which is going to be 15 over 25, which is also 3 over 5. So the ratio of my sides for cosine of angle L is going to be 3/5. Tangent, now tangent is the opposite over the adjacent. We don't have the opposite, right? I need to find the opposite, and how can I do that? Well, just remember, when dealing with a right triangle, a squared plus b squared is going to equal c squared, and I have a squared, I can call that 15. 15 squared plus b squared is going to equal c squared, and that is going to be 25 squared, because this is my hypotenuse. Let's see here, 225 plus b squared is equal to 625 minus 225 from both sides. B squared is going to be 400. Well, find the square root of both sides, and b is going to be 20. So I know over here that my opposite is going to be 20. So now I can figure out my other ratios, because my sine is going to be the opposite over the hypotenuse, which is going to be 20 over 25, or 4/5. And then the tangent is going to be the opposite over the adjacent, which is going to be 20 over 15, which is going to be 4/3. So the ratio, sine of L is the ratio of 4 over 5. cosine of L is the ratio 3 over 5, and then tangent of L is the ratio of 4 over 3. And there you have it, using those ratios to determine the ratios of the side lengths. And let's see here, what is the value of tangent of 60? Well, again, looking over here at this example, I know that I have a right triangle, but I'm missing this value over here, which would be b, right? And what I can do is I can say that a squared plus b squared equals c squared. And I know that a is going to be 6, so 6 squared plus b squared equals 12 squared. So I have 36 plus b squared equals 144. Subtract 36 from both sides. And then b squared is going to be equal to 108. Find the square root of both sides. And then b is going to be equal to, let's see, b is going to be equal to, and we're just going to say b is going to be equal to 10.4. So now when I'm looking at the tangent of 60 degrees, that is going to be the opposite over the adjacent, and this is going to be my opposite of angle B. And then the adjacent is going to be right here, 6. So that is going to equal the opposite, which is 10.4 over 6. And there you have it. You can simplify more than that, but the tangent of 60 degrees of this triangle is going to be 10.4 over 6. And then looking at this next example, we already have our sides in. Remember our SOHCAHTOA. And sine is going to be equal to the opposite over the adjacent. And then the cosine is going to be equal to the adjacent over the hypotenuse. And let's see here. So the sine of angle A, right? Sine of angle A right here is going to be 12 over 13. The sine of angle B, right, is going to be the opposite over the hypotenuse. So the sine of angle B is going to be 5 over 13. And then the cosine of angle A, well, the cosine is going to be the adjacent over the hypotenuse, which is going to be 5 over 13. And then your cosine of angle B is going to be the adjacent over the hypotenuse, which is going to be 12 over 13. Now, why did we do this? Well, what I want you to see here is, if you'll notice, the sine of angle A is the same as the cosine of the other angle. So the sine of one of the acute angles of a right triangle is equal to the cosine of the other acute angle, and vice versa. The cosine of the other one is equal to the sine of the other one. So just seeing that relationship, sort of a yin-yang, if you would say. So we could say that like the sine of an angle is equal to 90 degrees minus the cosine of an angle or something like that. But neither here nor there, but just understanding that sort of inverse relationship there. All right, so remember here that trig ratios are functions that take an input from an acute angle of a right triangle and produce an output. Great, we find the ratios of an angle are based on the sides of the acute. The ratios of the acute angles are based on the sides of the triangle. And remember SOHCAHTOA, we have sine is equal to the opposite over the hypotenuse. Sine opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. which is cosine is the adjacent over the hypotenuse, and then tangent is equal to the opposite over the adjacent. Tangent, opposite, adjacent. SOHCAHTOA. Now, real quick with this last thing, we have this triangle. And I'm going to have to assume that it is ABC, and it's a right triangle because they've given me some functions. And the sine of angle A, remember, is going to be the opposite over the hypotenuse. So the opposite of angle A is going to be right here. So that is going to be 1 over the hypotenuse is going to be 4. The cosine is going to be the adjacent. So the cosine of A is the adjacent over the hypotenuse. So the adjacent is going to be the square root of 15 over the hypotenuse, which we said was 4. Great. And then the tangent, let's just verify that. The tangent of angle A is going to be the opposite over the hypotenuse, which is 1 over the square root of 15. So there you have it. Able to plug those values in to see what my trig ratios are.